Here we are working with activity 2.2. This is the second video of activity 2.2, and we are going to be working with roots and radical notation. Okay, so basically that's really the core of what we are going to be talking about radical notation. Okay, so let's talk a little bit about what it means to take a root of a number. And let's start with something that you know, which is the square root of a number. So you know that the square root of 25 is 5. And you know that because 5 squared is equals to 25. Okay? So in a way, finding the square root of a number is kind of like the opposite of squaring the number. Right? So the square root of 25 is 5. Yeah? The square root of 4 is 2. Yes? Why? Because 2 squared is equals to 4. Right? But you may say, well, negative 2 squared is also equals to 4. Well, when we use the symbol square root of a, we mean the positive number. The positive number, right, whose square is a. Yes? So a number set to a positive number b, such as b squared, is equals to a. Okay? And of course, a has to be a positive number. Okay. So what I mean to say is that the square root of a is always positive. Even though negative 2 squared is equal to 4, we're not going to take that number. We're going to take the positive number. All right? Now, again, the square root of 16 is 4. Even though 4 squared and negative 4 squared equals to 16, we're going to take the positive number. Now, this number does not exist in the real numbers. If you look and you try to evaluate this in your calculator will tell you that this is not a real number. Okay? So I could have negative square root of 16. I can have that. How can I have that? Well, okay, because I know that this is 4, right? So I will have the 4, this 4 right here, and then this negative sign in front of it, negative 4. In other words, you are doing the square root, and then you are multiplying rather by negative 1. Okay, so let's review the properties of the square root. So first of all, I'm going to say that b is a square root, right? If b is a square root, if the square of b is equals to a. Okay? Now, the second property that we just talked about is that the square root of a means the positive. Okay? It has to be positive. And also, if we talk about square root of a has to be positive. So the square root of a is positive, and the number a must be positive when we're talking about the square root. So I would like to talk about now, let's just go to the next page. We want to talk about a root, not just square root, but any kind of root. Okay? So, for example, let's talk about the cube root, okay, of 8. Okay, the cube root of 8 is 2. And that is because if I take this number 2, right, and I set it to this power 3, I always get 8. Okay, so 2 to the third is equals to 8. Okay, now if I have the cubic root of negative 8, this is different than when I have the square root, right? I cannot have a square root of negative numbers, but I definitely can have the cube root of a negative number. the cube root of negative a is negative 2, because we all know that negative 2 to the third is negative a. In other words, you take this number right here, you set it to this exponent, and you get this number right here. Now, this is because this number right here, which is what I call the index of the root. So this guy right here is what I call the index of the root, right? In this case, the index is an odd number. Okay, so when the index is an odd number, I can have a radicand. In other words, the number under the radical can be negative, and the answer definitely is negative. Okay, so why don't we write some important concepts about what I'm going to call the nth root. Okay, the nth root. So don't get confused by me using the letter n. Okay, nth root of a number. What I mean to say is the fourth, the fifth, the sixth root. Okay, so I'm using the nth root. Okay, so first of all, I'm going to say that b is the nth root of a. In other words, b is the nth root of a. Yes, if and only if, what has to happen? b, right, to the n has to be equals to this number right here. So b to the n has to be equals to a. That's what makes b the nth root of a. Okay? So the second thing I need to remind you is that if a is positive, we just talked about that, a is positive and n is even. In other words, I'm going to give you an example. Square root of 4. Yes? The square, or rather the nth root of a, is going to be positive. Okay? Now, even roots of negative numbers are not real numbers. Even roots of negative numbers are not real numbers. Are not real. Okay? So what I would like to do now is I want to go to page 181, and again we are going to do the add problems in page 181. Again, remember that you are going to be working with the even problems, and that you should be checking on the back of your book for the answers to these problems. The answers start in page 831, all the way in the back of the book. All right? So let's start with problem number 19 in page 181. Remember, you're going to do the evens and you're going to be checking your answers. Okay, so we're talking about the cubic root of negative 27. So my first instinct is to say, oh my God, I have a negative number here. But don't panic. Make sure you look at the index. The index is an odd number. Because the index is an odd number, I'm okay. I can have a negative number under the radical. Now, the cubic root of negative 27 is that number that's set to the third power, right? That number that's set to the third power gives me negative 27. We all know that that number is negative 3. Negative 3 to the third power is negative 27. So this answer here is negative 3. Okay? All right, let's go with problem number 21. In problem number 21, I'm talking about the fourth root of 81. Now, this number right here is even. Yes? So in this case, this number has to be positive, and it is. So in other words, I'm looking for a number that set to the fourth power will give me 81. Okay? We all know that that number is 3. Yes? So the answer here for the number that represents the fourth root of 81 is 3. Okay? Again, this is positive and this is even, so this number has to be positive. Now let's go to problem number 23. We're talking about the square root of 4/9. Yes? So again, I'm talking about a number that's set to the second power will give me 4/9. Yes? So what number set to the second power will give me 4/9? Well, that I know what that is. I have to have a 2 in the numerator and I have to have a 3 in the denominator, right? Because if you multiply 2/3 times itself, right? You're going to multiply numerators and numerators and denominators and denominators, right? And then you get 4/9. So 2/3 to the second power is equal to 4/9. So the square root of 4/9 is 2/3. Okay, this is the video. This is the end of the video that relates to roots and radical notation. And you need to go to the next video, which is going to be working with fractional exponents of the form 1 divided by n and the form m divided by n. Okay, thank you.